So today we're going to look at solving equations involving fractions and decimals. So to handle the decimals, for example, in the first couple questions here, we're just going to normally do what we normally do for algebra. And in this situation we have an x plus 0.2 equals 0.8. You're just going to subtract 0.2 on both sides. Okay, these guys will cancel, that's the zero model. And in this situation, x is going to be equal to 0.8 minus 0.2, which is x equals 0.6. The rest of these, we're just going to handle them normally. Just like we would when we're dealing with any kind of numbers, we just have to use the order or the operations involving decimals. So nothing changes at all. The only times things get a little complicated is when we're dealing with the fractions, and we'll show you how to clear those fractions so that we make this a lot easier for you. Okay, so to do that, we'll move this up, and we'll do, for example, we'll do one that looks pretty challenging. We'll start with number 25, we'll do number 30, we'll do number 30, and then we'll say we'll do number 35. And we'll just show you the different examples. So, and again, it's the same thing as we did when we cleared fractions the first time, the other worksheet. We know that we can make a 1 here so that we all have fractions. It's probably the easiest way to do it so that you don't get confused with the whole number. I look at for what a common denominator could be, and in this situation I can make a common denominator of 6. So on both sides of the equation I'm going to multiply by 6. I've kept it balanced. I've kept the equal sign the same because I'm multiplying both sides by 6. Nothing changes. Left side equals right side. I know that there's a 1y there, a 1y there. I'll use my distributive property, and I get 6 times 1 is 6 divided by 2, and I get 3 y's left over. And that's going to equal distributive property. 6 times 1y is 6y, divided by 3 is 2y, and then 6 times a negative 1 is negative 6, and I don't have to worry about this because anything divided by 1 is the same number. And now I just have a regular equation. I can just move over the 2y on both sides. Zero model cancels that guy out. 3y minus 2y is 1y equals negative 6, and I'm done. Final answer. I'm going to clear this one. And now I think we said we would do number 30, so we'll do that one. Brackets. Sorry, I'll move that guy back up. Brackets x plus 1 divided by 3 equals x minus 1 divided by 5. The easiest common denominator will be 15. Again, I can multiply 3 and 5 to get 15. Okay, and then I'm going to distribute the 15 in. Now I don't have to distribute the 15 into the entire set of brackets. What I can do is I can say 15 x plus 1 equals 15 x minus 1. I haven't multiplied that yet, and I leave the denominators. Okay, I can cross this out to be left with 5 x plus 1 equals 3. I'm just dividing 15 divided by 3, 3 x minus 1. I'll then use distributive property, 5x plus 5, 3x minus 3. I will keep my largest one there, and I'll minus the 3x on this side, minus 3x on this side, to be left with 2x plus 5 equals negative 3. And I'm running out of space here, so I'll try to move it up. I don't know if that'll work. Oh, it did. Okay, so then I'm going to go minus 5, 2x equals negative 8. divide by 2, divide by 2, x equals negative 4. Now the key here is when I'm distributing the 15 to both sides, I don't have to distribute inside the brackets. I leave it outside the brackets. I can do that because we know that outside the bracket, just a bracket like this, when we had a question that looked like that before, we knew that there was a negative 1 there that we distributed in. So there is something there. It's not a negative. We can assume there's a number there. For our purposes, there's going to be. And then we can do the canceling here. And it saves us a lot. We get rid of the brackets, we use the distributive property, and then solve normally. So I'll clear this out. We'll try one more. So let's try, I think we said 35. So again, x plus 1 over 2 minus x minus 7 over 6 equals 3. I'm going to write that over 1. Common denominator here will be 6 because I can turn every number there into 6, so I will do that. Times 6, and again, it's the entire side. Okay, I'm going to distribute in. I'm going to put brackets here because I can do that. This is a term. And whatever that term gives me, I'm going to subtract this term by it. So when I'm multiplying and I'm distributing to clear those fractions, I'm going to multiply the 6 by the entire term. So you don't want to go 6 times x, 6 times 1, 6 times x, 6 times x, 6 times 1, 6 times... We don't want to do that. What we want to do is we want to leave these brackets mentally, I guess, if you want to call it that. And then you're going to go 6 times what's in brackets. We'll be left with 6 x plus 1 over 2 minus 6 x minus 7 over 6 equals 18. The 1 goes away. This will give me 3 x plus 1 minus, this will now cancel x minus 7, and I get 18. Now to get rid of the brackets, I'm going to want to distribute this negative sign in. So that's where it gets a little bit tricky, but we're going to have to do that. We're going to distribute this 3 in to be left with 3x plus 3 minus x plus 7 equals 18. And again, this negative sign will come inside the brackets. Because what I'm doing is I'm subtracting the entire term. I'm not just subtracting the x, I'm subtracting all of this here. So when I'm subtracting a negative 7, I'm actually adding it down here. It does get a bit confusing, but the use of brackets there will be very helpful. I will collect my like terms. 3x minus x is 2x. Plus 3 plus 7 plus 10 minus 10, 2x equals 8, and then we divide by 2 and we get x equal to 4. So I hope that helped. Again, for all of these, you're going to put some brackets in here. That will really help when you're starting to solve these. It will really help to put some brackets in. It will save you a lot of stress in the long run, even on this little n. Just get in the habit of putting brackets in these things. And you can do that because it's the entire term being divided by 3, not just a separate number. So if it's the entire term being divided by 3, let's put it into bracket. It will help us later on with the distributive property. So I hope that helped.